Hey guys, what's up? This is a continuation of the video about installation. You really liked the previous video, thank you for your support. There I talked about the main installation technologies used, and this video will also contain a lot of useful information, and it is dedicated specifically to what control points there are during editing, what are the flaws, why they arise, how to do it better and more correctly. For this video, here in front of me is this quality control checklist for installation. This is a document that created by me based on many years of experience, based on recommendations from system manufacturers, based on recommendations of some expert installation teams, installers, and so on. That is by trial and error, a bunch of mistakes, corrections, work with some incompetent installers, and so on. This document is really the foundation of everything, to be honest, and it's just hard to assess the usefulness of this video because I haven't shown this document to anyone yet. This is purely an internal document of mine, which I sent to the installation teams, according to which they work, according to which the technical supervision we check the objects, according to which I, accordingly, work. I didn't send it to anyone and didn't actually plan to make it publicly available, but my opinion has changed. I believe that I can share this information. I feel obligated to do so. In order to have more qualified professionals in the market, we still end up working with more or less the same installers. And I'm recording this video for installers, probably first and foremost. So, guys, if you're aluminum installers, please take a look because there's really an important point here, and I'm explaining why certain things are very important. This video may be of interest to installers who work with PVC windows, who want to improve their skills, and who work with aluminum. If anyone needs it, in principle, I can share this document. Write to me in the comments, and I'll send you this document. If you follow all these requirements, you'll achieve the highest level of quality in the installation of aluminum products. You'll understand everything and do everything correctly, so I recommend everyone. Watching this video will also be useful for my potential clients or any other clients. Yeah, or maybe even to my competitors, it doesn't really matter. In general, I want our people's qualifications to grow, the quality of editing to grow, so that I can be proud of my work and to compete with worthy guys, with respectable installation teams and reputable window companies. So let's start. It will be very interesting. Watch until the end. Of course, I can't keep all of this in my head, so I will refer to this document, look at some point here, tell you, explain, give an example from practice, yes, and move on. It might be a bit chaotic, jumping from facades to windows, and then back to windows, but that's not the point. We're just going to break down some key moments and discuss why it's important to control them, what mistakes can happen, and so on. All right, I won't keep you in suspense. First, to connect the post and the beam, you must use only special system screws, for example, like the one in Alutech, which has a flat head. What is this for? First, this screw is specially designed on the Alutech so that the rubber does not stick out. That is, if you use a regular screw with a round head or some other, there is a possibility that the rubber band may stick out. Not all installers can use, for example, another screw and bolt and trim the rubber, for example. Usually they don't do this. Then it sticks out a little bit, presses against the glass unit. Maybe even the glass unit will burst a little somewhere because the pressure in that place is high. It might not look very nice when the glazing unit is pressed and the sealant sticks out a bit. So let's do it right, using system screws with a flat head. For example, we're talking about Alutech, and the rubber sits nicely. The self-tapping screw doesn't catch on anything. Many installers complain to me that the heads of these screws come off, they get stripped, all that stuff. There are important points here. The first point is that the holes in the beam must be made precisely. They should be made a bit elongated, and they should be released in the groove for the rubber, like, well, the countersinking should be done, right? In Alutech, this is done on a special press mold. If you put the crossbar into this die, punch these holes, they will be perfect, and when the dry element is screwed onto the post and we put the beam on, everything will align perfectly. Of course, if the hole is off and it catches and they drilled it manually with a tape measure, then it's clear that the hole might not align perfectly. Then when you screw in that screw, it goes in crooked. It breaks because it's stainless steel. It's not that strong and it can break. So it's very important here. We're talking about ideal conditions. When the workshop has done everything right, well, you installers, you need to look at the beam. If you see that the holes are crooked, the holes, well, just straighten them out. If you see that there's no countersinking, well, just do the countersinking, because the head of this self-tapping screw can really come off. It comes off, in my opinion, in 3 cases. The first case is when the holes are not aligned with the dry element. The second case is when there's no countersinking. I had a lot of confusion about this. It seems trivial, but it's really not. Countersinks, the screw head does not go through. The installers do not make countersinks. The head rests against the groove of the rubber. It seems like it does not reach it all the way. They foolishly start to push it all in there, and the hat flies off. If they had just countersunk it a bit, it would have gone in smoothly. And the third reason is when the force on the screwdriver is too strong, So you need to understand that you can break something if you're not careful. You need to understand that the torque applied to the screws should be specific. You need to set it on the screwdriver in such a way that she was tightening everything up and at the same time the head didn't come off. And actually, experienced installers don't break anything. Everything connects perfectly with the system screws, so you need to use the system screws specifically, let's say, theoretically, to replace it with something else. Well, theoretically, yes, but the first thing must be stainless fasteners, and with some kind of countersunk head. Then the diameter should be more or less suitable. But there are installers, especially the PVC installers. They all have a bunch of them in their pockets. Those little ones, what are they called? Bugs or something. They're small. These self-tapping screws, the galvanized ones that they use on PVC windows, they screw everything with them, whatever it is. And they have a drill bit. They're convenient. They're galvanized. They're strong. And the heads don't break off. Well, of course, it is convenient, but it is wrong because there can be corrosion between the galvanized fasteners and the aluminum. This can actually lead to the screw or self-tapping screw breaking down over time, simply being eaten away by corrosion. And your product will just fall apart. I've even had cases where galvanized bolts were just corroded like that, and the heads would break off from a 10mm bolt. Well, this isn't from my personal experience. I've just heard stories like that where everything was completely eaten away by corrosion. So this is a fundamental rule. Forget about galvanized fasteners in aluminum structures. Only stainless self-tapping screws, only... If we use any galvanized elements, it should be done through stainless steel. For example, sometimes they use a stainless sleeve at the bottom and then a galvanized bolt goes into it. Then it is acceptable because stainless steel and aluminum do not corrode. Well, most of the time we still try to use all stainless steel, but there aren't enough screws. So I use a solution where I screw 2 Rigel screws into the post with 2 screws, and the cracker on which Rigel dresses, there's also a hole for screws there, and there are 2 more screws, so I always use 4 screws to connect the post with the Rigel. And experience has shown that this is the most correct, because if you choose cheaper crackers, when we have a cracker where there are no holes at all for the screw, it just kind of fits on, and there it is. It's fixed with 2 screws to the Rigel. In principle, you can probably do that for some small budget products. If you have a product with a post depth of 100mm or more, then using such a dry part is beneficial. Gaps between the post and the Rigel, it just separates and a gap appears there, right at the back of the post. So using 4 screws pulls everything together better, It just minimizes the gaps. All these gaps, plus it doesn't get as loose, it's somehow more reliable. So I recommend using 4 screws for each connection. How do we control this? This is a very important point. You need to check accordingly when the frame is assembled. Before installing the glass, we approach, bend the rubber, and check if all the screws are in place, if their heads are not broken, and if they are stainless steel. So this is a very, very important control point, and this needs to be monitored, checked, and the installers should adhere to this. Yes, I also wanted to mention that if you have a situation where the head of the screw has broken off and the screw is still there, here, accordingly, you need to somehow unscrew it. Try screw in a new one. There is no other way. Drill it out, maybe re-drill it. Well, we need to come up with something to get out of this situation and do it the right way. Second, the gap connection between the Rigel and the post. This is a very common problem because the system solution from Alutech or other manufacturers is either just a post with the Rigel joined end-to-end or through such a as a decorative plug for the Rigel. I don't know what to call it. It's plastic. I don't like these end caps of the Rigel at all. They don't look very nice. I never use them. If you use them, then you won't have any problems. But if you don't use them, like I do, and try to connect everything neatly, then you might run into this issue with many installers who aren't very professional, where the post and the Rigel have a gap that separates. Why could this happen? The first moment is when you are assembling and connecting the post to the Rigel. It's recommended to use straps, so we just take regular straps, like the ones used for cargo transport. There are the usual belts with which you put it out, put the Rigel struts, tightened them, well, so that there was no gap. Then you can screw in those holes, which helps to minimize this issue. But still, when you insert it into the opening and secure it, there might be a slight gap that opens up because you're securing the post, and the base might twist, which can pull the post out of alignment. So you need to be careful. Always make the fasteners so that the racks are pressed against the maximum regulators, so that no gaps appear. That is, we try to tighten the fasteners a little bit, yes? Well, either evenly or a little bit. It still tightens, but under no circumstances should you stretch the fasteners, as that would create gaps. If you're installing in an opening, you can also place wedges around the Rigel to push the post a bit closer to the Rigel. If the installation is on an overhang, of course, it's harder to do that. You really need to try to secure everything in a way that avoids those gaps. But still, of course, there might be some minimal gap. In principle, it is acceptable. They're a millimeter maximum. I don't know if there is a micro gap, some kind of one. It is not possible to tighten it in any way. There, the wedges have already been unfolded with fasteners, wedges. Well, it doesn't work. I don't know. Well, this rarely happens to me. But installers who really know how to do it, this never happens to them. Well, some people do run into it, actually. It's acceptable to take some sealant that matches the color and just carefully apply it to that gap so it isn't visible. That is, in principle, this is kind of acceptable, but if it's 2 to 3 millimeters, it's clear that it's just so-so. You shouldn't just cover it up with sealant. I'm talking about very minimal issues. So if we're talking about a control point, you need to approach and check the connection between the rigel and the post to make sure there are no gaps. This is a very important point, and you need to know how to connect everything properly. The third point is that the rigel is not fully pressed against the post because the screws are not tightened. I've had such cases, and it's very important here. I always use coplanar posts with rigels, meaning they are in the same plane at the back from the inside. I really like it this way. I prefer doing it like this because it looks nicer and it's easier to approach from the floor and the ceiling. You don't have to go around each post. We have one plane. We approached and the floor of the rigel is all nice and even. So, here. When we talk about being coplanar, the post and the rigel should be in the same plane. But for example, I had a situation where the rigel was a bit deeper. It's pushing a bit outside by about 2-3 millimeters. It shouldn't be like that. It's a bit deeper just by a minimal amount of millimeters or so. Just a little. If it's deeper, then that's not normal. You need to take a look at it. Respectively, that's if it's coplanar. If your crossbar is shorter than the rack, then this can be seen precisely at the joint. This is where the crossbar overlaps the rack. Is there any gap formed there? There shouldn't be one. So the rigel should fit as tightly as possible against the post. So here's the post. We put the rigel on it and screw it in, making sure it fits as tightly as possible. I've just had cases where the guys didn't tighten it properly. They didn't tighten the screws, they didn't tighten the rigel, and everything has already been assembled. So the rigel is not fully tightened. And which is very important. The rubber ends up not being in the same plane. So the rigel is pulling and the rubber seals are sticking out too. And when we install the glass unit, if such a situation occurs, and God forbid, the installers start pulling it too tightly, the glass unit can crack or just break apart. This happens because it's being twisted due to the seals not being in the same plane. So this moment definitely needs to be monitored. Just walk around and check if the rigels are tightly secured to the posts everywhere. Check if there are any gaps formed anywhere or if something has come loose and so on. So, well, this is such an important control point. Doors and windows must be secured to the post and beam system with screws. This solution is from the Alutech catalog or other manufacturers. It doesn't matter. Any window or door must be secured to the post and beam system. It has been installed and screwed in. At Alutech, this is done with long screws from the street side under the pressure strip. Then these screws are hidden, so with a step of 450 millimeters, long screws enter the rack and press this door. It is acceptable to do this through the frame, but then you need to put plugs and screws there and select them. And that's not very pretty, so we really try to, in a way that effectively screw in these long screws from the outside to securely secure the door or window to the post and beam system, ensuring everything is firmly in place. Many installers don't do this. They just press it down with clamps, and then it turns out this door can move, shift, deform, sag, or bend in some way. This can lead to problems with the door or window later on, because the frame isn't securely fixed to the post and beam system. So that's such an important point. It needs to be secured tightly around the perimeter to the post and beam system. There should always be a Paronite gasket between the mounting plate and the base. So right now we're talking about the installation of the post and beam system. And when we attach the post to the opening, so we apply it from the bottom and the top, or aluminum mounting plates, or some steel plates, or it could be brackets that are attached to the concrete from the side, from the top, or from the bottom, well, it doesn't matter. There should always be a Paronite gasket or between the fastener and the concrete. I use a millimeter, and I think that's enough. This is necessary so that regardless, between concrete and metal, aluminum or steel, some kind of corrosion may also occur there. It's a chemical process and not a good one, so these Paronite gaskets are essential. Many installers don't do this. You bring it, there is no steam, they don't install it, or, for example, they forgot to buy the Paronite or something else wasn't brought, and they just didn't do it. They just screwed it in without caring. This should not be mandatory. There should be gaskets. Therefore, if they are not there, please unscrew, insert. Then it means that we are redoing, because without this, the pair will definitely not pass. There should always be further. Here I have a point about sealing the top part of the post. Actually, this is an unusual solution, and it's not used everywhere. Not all installers apply it, and even not all system manufacturers use it. That is, but as it is here in the recommendations for editing Alutech, I will tell about it. Honestly, I can't even say exactly why this is necessary, but we do it this way sometimes, and sometimes we don't. That is, here is the top one. So, there's an embedded part in the post that fits in, and it has some play, meaning it's not rigidly fixed there. Because at the bottom, the reinforcement is rigid, while the top of the post moves with the embedded part due to thermal expansion, and so gaps form between the post and the embedded part, like this from the top, these gaps. Alutech recommends sealing it, filling it with sealant. I don't know, maybe it's because some condensation might form there or something else could happen. Blowing, I don't really understand what could be going on there because it's indoors. Everything on your bed is sealed. But still, there are such recommendations. Maybe if Alutech representatives are watching me, and not necessarily I think someone is watching, please tell us in the comments why this is necessary and why they recommend it to those people. I myself would be interested in sealing this upper part of the rack. If this is really important, then we'll keep doing it this way in the future. The next point is sealing the seals between the rack and the crossbar. There is a special sealant that Alutech recommends, Cosmo 4-on-12. You can, of course, use other sealants. It doesn't really matter. It just needs to be some kind of elastic sealant, a black one for sealing rubber gaskets made from EPDM material. What is this necessary for? Many people don't do this either. They think it's some kind of nonsense. So, the post and the beam, they come in a disassembled state, right? And the gasket is installed on the beam and on the post. And when we connect it, these gaskets are trimmed and they come together like this. And at the junction of these gaskets, you need to seal it properly. You pour a little, bend the gasket, pour a bit into the beam, into the post, and then pour between them and connect. I have a video from my installer, the most experienced one, Sash. He's a really cool installer. He handles about 80% of my projects. Well, that's really top-notch, a specialist level, so if needed, of course, I can share with someone, but after he finishes everything for me. Why are we doing this? Let me explain. I asked Alutech and said, guys, what's the point of doing this? What's the advantage? They say that they conducted tests, and that indeed, when they blew air under pressure, the instruments showed that in the places where the seals meet, well, there is a leak, let's say, light, some kind of blowing that you won't feel, an ordinary person won't understand it, but the design, if you seal the seals, will be more airtight, more reliable, more durable, so this recommendation really exists. I tell all the installers that they must do this. I recommend to you, those of you watching me who are installers, not to be lazy and to do this. I had a case, I'm telling you about another company I worked for when I was employed, and we installed these, and the systems are installed by beam installers, of course, but I can tell you for sure, 90% of installers don't do this. The installers were experienced, but they didn't do it because we had never done it that way before. Accordingly, the client has the right to call representatives from Alutech. So guys, I bought Alutech windows and I asked them to come and conduct an inspection for me. The Alutech representative comes and documents everything in a report. Alutech will not cover up the installation company there or the window company. They describe everything as per Alutech standards, and he accordingly, there were some minor remarks, and he noted that there was no sealing between the beam and the vertical gasket. The client insists, do it. It's required, just do it. We already have the double glazed windows installed. The whole cottage is glazed. And to do this, you need to pull out a huge amount of money from the double glazed unit. So they kind of spread the gasket a bit there, poured some sealant in. The client, accordingly, they were giving some huge additional discount to kind of cover this up. So a real problem has arisen. And if you're an installer and you're installing and you find that this is a problem, maybe I would like to touch upon you, among other things, because I am currently working only under a contract. And if, roughly speaking, a situation arises where the client points this out and says, I'm not satisfied with this, then you'll have to redo it accordingly. You'll end up losing money, and what if you don't? If you have an agreement with the window company, then it will fall on that window company. Why do we need this? Let's all agree in the market that this is necessary, and let's do it. Yes, it takes a bit longer. Yeah, it's a bit of a hassle, but it's quality work done right and reliable. So, make sure to seal the joints of the gaskets together. Drip edge. What is a drip edge? The drip edge is installed by us. It's attached to the post, and it serves to drain water and condensation that collects. The vertical beam system works on the principle that the beam overlaps the post. Any condensation that may collect in the beam's false edges falls onto the beam, flows along it, and then drains into the post. There are grooves in the post where the water flows, and then it exits through the drip edge. In reality, there can actually be a lot of water, so the dew point passes through. Temperature fluctuations create a lot of condensation, and installing drip edges is just a crucial process. It's really important, but everyone tends to overlook it. I'm explaining what needs to be done. The drip edge should be installed in the workshop with sealant and screwed in with self-tapping screws. From the bottom, the post at a certain point at the level of the lower beams can be lower, but they cannot be higher. If it's above the beams, then water will flow from the beams under the drip edge, but we need it to flow onto the drip edge. Accordingly, at the level of the lower rails, a drip cap is installed. The installer checks that the hijack is installed, was correctly attached to the rack, screwed on with sealant, if there is no sealant. In the workshop, if it wasn't sealed, you need to unscrew it, seal it, and if it somehow came off, reattach it properly and seal it. Accordingly, after installing the lower drip edge, the upper drip edge is also installed, and it should be mirrored like this. This drip edge is needed at the top for ventilation, meaning we have an opening at the bottom and an opening at the top for airflow. This is how it circulates and evaporates this kind of excess moisture, which can form droplets on the counter. Well, that's what the manufacturers recommend. They say that the upper drip edge isn't necessarily required, and it goes back and forth. Well, there are recommendations. We're making the upper drip edge and the lower drip edge. So the lower drip edge, when we install it, is always long, with all manufacturers, allowing for different thicknesses of the glass unit. Here it is, it's long like this. Next, when we install the glass unit and then put on the pressure plate, the drip edge sticks out from it over a considerable distance. It needs to be trimmed correctly in the right shape. There are special scissors for that, or you can use a knife to do it. It's not just a simple cut. You have to shape the tip like this when you cut it. So there are certain requirements. These requirements are in the Alutech catalog, how to trim the drip edge, at what thickness. There are even marks and little lines on it indicating where to cut. This definitely needs to be done. I just had a bunch of cases where the drip edges were in the workshop, the installers put in the glass units, and the pressure plates were pushed into the openings. This drip edge, by the way, there must be a hole in the pressure plate. If it wasn't done in the workshop, then you have to drill it on site and pull out the drip edge. The point is to divert water away from the post, and it should get between the cap and the pressure plate, then flow out to the sill somewhere beyond our structure. So, what did they do? They installed this drip edge, screwed on the pressure plate, and there it is sticking out by 2 or 3 centimeters. They just nailed the cap on top of it, the drip edge. This is how it gets bent, sticking down like this. What is this? This is not normal. Everything is covered with the cap. That's how they pinched it, blocking the water drainage, and now it doesn't work anymore. It didn't even occur to us that there was something sticking out too much. Maybe it needed to be trimmed. They just pinched it. If it gets pinched down, sometimes they pinch it at the top too, and it just gets bent. So what's the point of it at all? So make sure you know how to check this. It's an important control point to see if the drip edges are installed, if they're installed correctly, and if they're sealed properly. Because if the drip edge is poorly installed and there are gaps in the seals of the posts, then water will go down. The installation joint will destroy the base of the mounting foam. If there is mold there, then this is a critically important point, properly installed drip edges. And accordingly, tie them down by depth. Alutech also recommends that when the drip edge is installed and a foam thermal bridge approaches it, you should seal between them. Well, we do that sometimes, but I don't think this requirement is very critical either. Basically, I think it's not necessary to do this, but it's preferable. Also, representatives of Alutech, please write in the comments, hi Queen, why you drew or not the seal between the foam insulation and the drip. How critical is this? How important is it? Well, probably because capillary moisture can also form in the foam insulation. Some kind of moisture can form. And there are also these grooves, right? So it flows. And it's important for us that water flows not only from the very tip of the beam, but also from this foam thermal bridge. So yes, sealing is definitely very important here at the bottom, because water can leak from the lower beam between the drip edge and the thermal bridge. This foam one. So yes, this requirement is really important. I will emphasize this when I talk to my installers, and my installers will be watching everything. You definitely need to watch this video. If you don't take a look, then they will all be processed, and checking the correct fastening of the drainage level is also an important point. We assembled our structure with precise adjustments and installed it in the opening. Before installing the glass units, it's necessary to set the bottom part level with a clean floor using a laser and secure it with a rigid connection. Usually this is done at the bottom if it's the lower support system. Right now we're not talking about the upper parts, suspended elements, or any nuances. We're discussing classic installation. So the most common and widespread practice is to extend the post from the bottom. Here is the beam, and the post is slightly extended from the bottom to make room for installing a bolt that has a diameter of 16 millimeters. It just flew through. A hole is made. An aluminum sleeve is inserted there. A stainless steel bolt is put into the sleeve, and then everything is tightened. Why do we need a sleeve? Because the sleeve acts as a spacer. It prevents the bolt from over-tightening and crushing the post. So the sleeves are absolutely necessary. They are installed both at the very bottom, and also if you have any surrounding support brackets, a protective sleeve is always used because it effectively prevents over-tightening issues. And it's exactly 50 millimeters in width, precisely just like the post itself. Very, very, very. So if you have an extended post, you should have bolts at the bottom. If they're small in depth, then 1 bolt is enough. Usually 2 bolts are installed, sometimes even 3, depending on the design and load. But probably most often it's 2 bolts. At the bottom, we're checking to make sure everything is level and that the bolts are secured at the bottom. If you don't have an extension on the post at the bottom, there are two options. The first option is, if the glass unit is less than 200 kilograms, which is small, then you can secure it with self-tapping screws. Here is the street side. You can screw the self-tapping screws directly into the post like this, meaning the embedded part goes into the post and we need to connect them together, right? Firmly. So we screw the post into the embedded part with self-tapping screws. 4 to 6 self-tapping screws on the side of the seals. If you have small glass units, that's acceptable. It's a systematic solution. If you have large glass units with significant weight, then of course it won't work and you need to make a fastening, then it will be visible on 3 helios. Basically, there's nothing really scary about this. There is a stainless steel sleeve 50 millimeters with an M8 screw thread, 20 millimeters long. Such with a concealed and decorative washer made of stainless steel. We kind of insert a bushing, 2 washers, decorative, tighten 2 screws, and get such a beautiful mount on the trigger. Tighten here also with the King 12, depending on what load and is allowed there, because the same washers and screws are used. For example, on the structural corner on the beam, they are connected, or on the winter garden, where we have a bend in the rack with the beam, the same screws are used. So it's a perfectly normal looking solution. Yes, it is stainless steel. In principle, it can be painted. Some people bother to paint it, but mostly they just leave it in its stainless form. Washers, screws, it looks perfectly fine. So this moment of securing the bottom level is very important, because all the load from the weight, so all the products of all the glass units will be supported by these lower fasteners, so we need to keep an eye on them. A thermal bridge must be installed, either plastic or foam. It would seem that it would be impossible not to put it there, but I'm telling you from experience that there was more than one case, and with more than one installation team, when we brought them a thermal bridge, a butyl tape, it arrived with the product, but they didn't install it. That is, they installed the frame, installed the glass, and immediately pressed it down with pressure strips and self-tapping screws. And they just don't install it. And what's left over just makes my hair stand on end. I say, how is this possible? Install it. If you have a thermal bridge lying around, there is a butyl tape lying around. If you don't know where it goes, at least ask and I will explain it to you. But you can't just put it there and, as is customary with us, like, yes, this is unnecessary. That's how it is. Of course, there can't be anything extra. Nothing can be on the site. If something has arrived, then it is intended for something. If you don't know what it's for, you ask the specialists and they explain it to you. It only works that way, so the thermal bridge must definitely be installed. I only use foam thermal bridges because that way the system is warmer. Plastic thermal bridges are cheap. They're sometimes used in commercial projects, some less responsible ones that may be in industrial buildings or stores where they need to cut costs. You can use a plastic thermal bridge there. If it's foam, then I use foam. It gets inserted after the installation of the double glazed window, so you need to push it in there. And the self-tapping screw then goes through it, which presses the double glazed window. Clamping strip after you've installed the foam insulation. You need to apply the butyl tape. Some manufacturers there, like Master, say that it is enough to glue the butyl tape only in a cross shape at the joint of the glass units, and then it is not needed, or the same one says that it needs to be glued everywhere along the entire length. Shuka also applies it everywhere. That's why I'm a proponent of applying the butyl tape along the entire length first, and only then installing the clamping strip. The butyl tape is really important because it provides additional sealing. You have the clamping strip. It may have moved away a little somewhere, it may not have been pressed tightly somewhere, the rubber may have dried out there, but water may still leak out. The butyl tape is a protection that prevents water from flowing in further. It will simply flow along the butyl tape, as if, and go away, and will not get inside the product. So, in my opinion, the butyl tape is very important, and it needs to be applied correctly and properly. And it should be of good quality, especially when you have a connection of the posts, like a thermal break in a large product, say 6 meters. There's a slab, the ceilings are on the slab, the connections of the ceilings are set up so they connect like this, buddy. The brackets are connected through a mounting plate and secured with a bracket. There's a technical solution where a special sleeve is installed and this joint is all sealed up. Well, here, I think it is important to really seal it, so pay attention to the fact that this thermal break, this joint of the racks, must be done correctly. There's sealing with sleeves or just sealing, but it should be done smartly. I also have recommendations on this from the catalog regarding how to do everything correctly. And I, accordingly, included the application for fastening the drainage beam system in this document. I recommend fastening to concrete. Usually the post is secured up and down to the concrete beam or to some dense material like solid brick. So I recommend using an anchor bolt that's about 100 million long, like a 10 by 100, for example. You need to check that there are exactly 2 fasteners, 2 anchor bolts at the bottom and 2 at the top. what happens is that the installers, I don't know, maybe they ran out of anchor bolts or something, or they just take some kind of nail and screw it into the concrete thinking, well, it's secured, it won't go anywhere. I can't do it that way, so let's make sure we have a good securely fastened anchor in the concrete so that they are properly drilled, properly screwed in and tightened all the way. We check to make sure they aren't loose. If you need to tighten it, we tighten it. There must be reliable and good quality fastening because lightweight systems are usually large stained glass windows. These are large loads, large weights. So fastening to concrete with anchors, especially if it's cantilevered somewhere, is a very important process. If you do it poorly, everything will fall. So we definitely monitor the tightening of the anchor bolts, check the correctness of the installation, the number of anchor bolts installed, and so on. Here we have the Paronite gasket, which I mentioned earlier. Oh, now there's going to be a little reference to window systems. The mounting plate should be attached to the window and door frames using only stainless steel screws, and only to the inner cup of the profile. Yeah, oh, guys, I have this interesting story. So, look, with PVC windows, when the mounting plate is installed, they are fastened right in the center of the frame with a galvanized self-tapping screw. So these bugs, well, not bugs, but those with a drill, yeah, they screw it in, and this plate is screwed into the steel reinforcement that's inside the profile. That's how PVC installers and many other installers are used to working. When it comes to aluminum, many installers do not understand why it is necessary to screw the mounting plate only into the inner chamber. You can't screw the mounting plate into the thermal brake. The thermal brake is not load-bearing. It won't support the product. You need to screw it specifically into the aluminum, specifically into the inner chamber. You also can't screw into the outer chamber because it's outside. It's cold. You'll feel cold at the bridge on the mounting plate. Only the inner chamber. Only stainless steel fasteners because these mounting plates are often twisted and galvanized screws will come into play. I repeat once again, only stainless steel fasteners. And I just had a case where people screwed these plates in with self-tapping screws. And when you approach the product from the outside, you can clearly see that the plate is attached with a self-tapping screw, and it's not even at the very edge. They screwed the plates in, yeah, with a slight offset. So when they screwed it into the thermal brake, the plate sticks out right into the street. So, well, you approach it, and I'll send you a photo. I have a picture of the object. Where the plate is screwed into the thermal brake, part of that plate touches the outer shell of the profile and even sticks out into the street. This will definitely lead to freezing, condensation, and then it will get moldy, rust, and fall apart. So, this means a complete reinstallation right away. It is necessary to understand that the plates must be screwed only into the inner cup, I repeat, and only not with rusty kopech. This is a very important point. It would seem that this is such a banality, but for some reason many people do not understand this and do not do it. Installers, pay attention to this. Often on projects when installing windows, in a wooden house, there should always be a frame in a wooden house. Because the house is settling, it plays at home, a sheet of laminated veneer, lumber, or some kind of log, it doesn't matter, it should be façade. Accordingly, the fastening in façade has certain nuances. I had a project where we were fastening to the frame, and the installer sent different lengths. Depending on the different situations, these are on gels or turboprops, here they are. We have, according to the project, they did not drill the first chamber, but screwed this screw into the casing directly through the frame, through 2 chambers. The screw was of a certain length, calculated. They drilled a hole and screwed it into the far wall with this screw. The screw went through the frame and into the foundation of the house. And they didn't even think, that something was off, that it shouldn't be like this. But this is a very important point because the screws should not touch the foundation of the house. The frame and the window live separately. From the foundation of the house, do you understand the essence of the frame? Why is it made like that? In order for it to move between the foundation, the wall, and the frame, there is a kind of movement. It moves in the grooves. And when the house settles, your window doesn't get skewed. It stays in place. If you screw into the foundation of the house, when the house settles, your window will just get skewed. It will twist out of place. Somewhere the gaps will widen, the sashes will stop opening, and the seals will burst. I don't know. There can be big problems. So this is a very important point. It's important to make sure that the fasteners don't stick out too deep beyond the frame. It was supposed to fit exactly into the frame, not further. There is a gap between the frame and the foundation. It can go in a little bit, but specifically it shouldn't go into the foundation of the house. The attachment of this mounting plate, if we have plates, should be at least at 2 points, according to the standards. The distance between the points should be at least 40 mm. The fixation can be done with a mounting plate or with dowels, concrete, or with some kind of turbo screws for softer materials like foam blocks and so on. So here it's important to view project coordinate with, I don't know about the surveyors there, I have everything drawn out in the project. So what kind of fasteners, where the screws are, where the plates are, and where there are no plates, all of this is drawn in the project. If we're fastening up into ceramic blocks, we need to use either turbo screws or special screws or nylon ones. The 10 by 100 dowels are large, or the chemical anchors. Regular dowels or nails won't hold in ceramic blocks. That is, I simply had many cases when the installers, they installed whatever they wanted, not what was actually delivered to them. They twisted in some nails like this. The fingers come out of the ceramic block, nothing holds, it just spins. Also, they were drilling there with a hammer drill, but you need to drill into the ceramic block with a non-hammer drill or a special drill. They're some kind of diamond-coated drill for ceramics. Well, that is, there must be the right tool, the right drill, the right fastener. Then everything will work. If you have a technical department, a designer, or someone who thinks this through at the pre-installation stage and brings the correct fasteners, then your job as an installer is to simply take the drawing and do what is drawn. There is no fool there. He drew it, of course. If you have such companies that they do not work according to the project, there they just go by the measurement sheet and the installers fasten things however they want, but you should then read up, study that information, and choose the right fasteners for the right material. In foam blocks, your own. In grams block, your own. In concrete, your own. And everything should hold firmly where you need to use chemical anchors, and where you don't need to use chemicals, there shouldn't be any ISO debris under the mounting plate. And it shouldn't be hanging in the air, it should fit snugly against the wall. But this is also a unique case when we installed it in winter and there was ice on the base, yes, on the windowsill, well, somewhere, I don't know, maybe up to a centimeter thick. And instead of breaking the ice and properly installing the window on a solid base, then sealing it with foam and securing the plate, I have a photo where the installers just attach the plate directly onto the ice. But no, and I just don't get it. Well, the ice will melt later, so what? So is it going to be loose? Well, how do you secure a plate to ice? Make sure that the opening is cleared of ice, any debris, dust, dirt, and any stones, I don't know, extra tape, and so on. You need to secure it to the base so that the plate fits snugly. And an important point is to bend it correctly. So the plate should bend near the frame, and it should bend like this against the wall. It shouldn't just go straight from the frame, like this, you know, going off diagonally. It shouldn't be like that. You need to bend it correctly. So it bends along the frame like this, then it presses against the wall, and then it's nailed down. So like this, you know, in the shape of a Z, it should look as close to 90 degrees as possible, maybe with a slight angle. But it's not like she just stood there like this, like she stood there, yes, exactly like this. Well, they just pressed her down like this and put her there. She goes at an angle like this. It shouldn't be like that. You need to bend it first and then nail it down. That's right. Plate location. So it shouldn't be sticking out from the wall in any way. It should fit snugly against the wall. But the fastening should be screwed in correctly, and I recommend securing it under the gutter in this document. That is, as we do, we usually bring in products, sliding doors. This can be a very large product. The frame can be disassembled or it can be assembled. The sashes can be installed there as well as separately depending on the product. Well, let's say we got the doors, we have the frame. With such gutters, the gutters are installed in a sliding system at the bottom, on the side, at the top. It doesn't matter. We carefully take out these gutters. They can sometimes be sealed in the workshop, but that's not a problem. You can tear them off there, but when we put them back, we definitely need to seal them because the water in the gutter shouldn't leak through that gap. Make sure to seal the gutters when you insert them. So we take out the gutters and secure our frame with turbo screws with a specific spacing from the bottom. This is 350 millimeters, 350, 400 at most, according to the Alutech catalog 350. The spacing for the fasteners is at the bottom. I was shocked too, yeah, it happens often, but you really need to secure the bottom frame like that. 350 millimeters, we secure it with turbo screws, making sure everything is level, using wedges and some adjustable supports. I talked about this in the previous video. Accordingly, we set everything up, fasten it, then install the gutter. It covers these turbo props. And dowels, yes. Of course, you cannot attach it under the gutter. You can attach it there with visible fasteners exactly in the profile bowl, but not through the gutter. This is generally not allowed. You can't make holes in the gutter, forget it, no. Through the gutter, I had the same thing. They attached it through the gutter. There were holes there, then they remained. The gutter was changed because even if these holes get clogged, there is a risk of water falling in. So we either secure it under the gutter or into the aluminum frame, fastening it into the cup. We might have to put in some plugs or something to cover those holes. The holes are visible, which is why I like the fastening, because it is not visible. There is a step on the side. The fastening is larger there, somewhere around 600 millimeters. But we also fasten the gutter. Then we install all these complaints, seal them. It turns out great, beautiful, and reliable. Oh, this is such an interesting moment. That was a sad experience in my life. There are supports for the double glazed units. So this is the facade system, and it has special supports inserted into the beams. It's an aluminum support, and then there's a leveling pad, a little plate, and then the double glazed unit. First of all, the leveling pads must be plastic. I've seen guys actually put the double glazed units on those aluminum supports. That's absolutely unacceptable. You can't do that because, well, it will just crack. The glass will break. You can't put it on aluminum. So these supports, there are just dozens of types of them. For different depths of double glazed units, there are standard little strips that you can attach. And then there are reinforced ones, and there are also cross-shaped ones. There are even some steel ones, so there are also some non-standard steel brackets. There are really, really many different options for these supports, and it is very important. If you are not given this information and you do not understand which support goes where, it's necessary to study the documentation of Gorn and figure it out and distribute these supports on the site with a full understanding that these supports are meant for this double glazed unit. These are for this large double glazed unit, and here we have a reinforced support. There's a smaller double glazed unit there, so it has a regular support. It is very important that these supports are installed correctly, especially the reinforced support. I'll show an image on the screen now. There's a little nozzle there, and we were installing cross-shaped supports. There's a cross-shaped support that comes in disassembly. The vertical part is attached to the post, and the horizontal part is attached to the beam, and it gets screwed with screws. It's either an L-shaped or a T-shaped one. A cross-shaped support. This is for heavy, large double-glazed units. Respectively, the installers twisted these cross-shaped pores, and even when I was at the site, I didn't pay attention to it. And accordingly, this lower platform was screwed on. Not the way it should be, but in a mirror image. On the contrary, it turned out that this little nozzle is sticking out there at the bottom. It ended up being at the bottom, but it should have been at the top. What happened was they installed the double glazed units and laid the shims, the plastic ones. No one paid attention to it. Then the sun warmed up and a month went by. We arrive at the site and see that the outer glass has just slipped down. Like this, by 5-6 millimeters. All the frames are twisted because the bottom support was installed incorrectly. We had to dismantle everything there. They were changing the double glazed units and flipping them over. These supports are there to make sure the glass is laid down properly. This is such an important point that I honestly don't even know how to convey it. You must, as installers or as inspectors, check that all the glass, double glazed windows, 3-chamber glass, all the glass should rest on this support. The glass can't just hang in the air. If the support is too short, then it means it's been chosen incorrectly. Or it was delivered incorrectly, or it was ordered incorrectly, or the installers put it in wrong, or it might even be upside down. You need to keep an eye on it to make sure that all 3 panes of glass are resting on the support. An incredibly important point. Moreover, they must lie 3 glasses equal both on the aluminum support and on the straightening pad. What happens is that they put a lining on an aluminum support. The thickness is also in depth, or they took the wrong one, or they pushed it in too deep, and it ended up going in further, leaving no support under the outer glass. And here it is, for example, 5 millimeters. Believe me, those 5 millimeters matter. The outer glass will slide down, hit the aluminum support, that is, it will slide past our plastic one, hit the aluminum support, and will simply press. In the end, if the glass is tempered, it will shatter like this. If it's not, then a crack will definitely form, that's for sure. I've had cases like that too. When my installers incorrectly placed the shims at the wrong depth, they even took extra measures to make sure everything was secure. They put up aluminum supports and straighteners, not like owls, but like this. They turn it like this, but they are 100 there. Let's say there are 50 of us there. They unfold them like this in lengths of 2 by 3 pieces. I insert it. They put the bag in place, and then they cut the edge of the bag with a knife to be absolutely sure that this lining won't move anywhere, and all the glass will lie flat on the lining. An incredibly important point. You need to watch this, follow it, pay attention to it, because you can't even imagine what problems this can lead to. Well, I've more or less explained it, right? Replacing double glazed units, complete glass destruction, it will slide down, break, fall apart. So, this is a critical moment. The reinforced shim, which is reinforced in Alutech, is additionally secured with screws to the beam. These screws need to be special. It's indicated here in the catalog. 5F23 screws, specifically designed for this shim. Don't just twist it around with whatever you have on hand. You understand? You need to take the screw that should be there and install it there. If he hasn't arrived yet, just say that he brought it. The scheme of installation wedges. Oh, that's a topic. It seems so, right? All the installers know how to wedge a window. What's so special about this, damn it? PVC installers know how to wedge PVC. Yeah, no way, damn it. they don't know how. I'm surprised. That's why I included a diagram in this document showing how to properly install the wedges in the window. They should be in the corners, they should be around the imposts, at what intervals they should be placed, and how far from the attachment point these wedges should be. Here's the entire diagram, so make sure to study it, but don't be lazy. Even if you think you know, here's the installer who's looking. Well, look at this diagram. Say, yeah, basically, yeah, there. Well, take this document, print it out. You can't remember everything in your head. So you're installing it like this. Here's the window, right? This is the scheme. This is the wedging scheme. But wedge according to the scheme. Then you'll automatically have the shower set up already properly wedged everywhere. Doors have their own scheme. Windows have their own scheme. So here are all these diagrams. And next is the diagram of the attachment points. It's also an incredibly important point. For some reason, they secure it, in the sense of, well, the knife won't fall out, and that's fine. And the fact that there are certain standards, there are standards defined by GOST, there are standards defined there. Here are the system manufacturers, and I have like the technical supervisors and installers also keeping an eye on things, and the installers send me videos. I always keep an eye on this, and if necessary, I tell them to add more fasteners, because it needs to be 150 millimeters from the corner, the attachment point from each corner here and there from the impost, 150 millimeters on each side. The distance between the fasteners should be about 700 millimeters, not more. Wherever you connect two products together, it should either be foamed or have a PSB inserted. So what are the sealing materials? What should be used? Well, in general, the attachment scheme for windows and doors is specified. In this document, I recommend studying and sticking to this attachment scheme, the wedging scheme for the sashes. This is also a very important point because surprisingly, I just don't know. I've had cases where all the sashes just sagged, the client was like, what the hell? I'm sending a service crew there. It turns out to be the installers. Well, there was a crew that wasn't very reliable. We take out the beads, the gaskets, and all the sashes are just wedged. It was done incorrectly, and the crew wasn't very experienced with aluminum. Well, they talked about PVC. We've been installing it for 20 years. And aluminum too. They also said that they install it in the end. Wedge adjustment is a very important point specifically for the glass unit of the sash, because if the welding on the glass unit is not wedged correctly, it will sag. The distribution goes from hinges are placed diagonally, that is in the area of the hinge like this, then there are more diagonally. Well, there is a specific scheme here. A casement window is one scheme, a tilt and turn window, another layout scheme for these spacers. There, it's like there's a spacer and alignment going on in the aluminum accordingly. The fixed ones are one, the turnable ones are another. For another type, there are tilt ones for the third frame, and then there's the door scheme, which is the fifth scheme. Shimming, a certain method of wedging and sliding. Without understanding the wedge, the sliding system, how to do it right, nothing will come together for you. I can guarantee you that I had cases when the guys just installed inexperienced ones, and that's it. Well, it doesn't fit with the gap, it doesn't fit with the frame, it doesn't fit with the frame, it doesn't fit with the frame itself. Another team of more experienced guys arrives, they take out the stuff, and that's it. The wedging is wrong. Although I sent the document, no one reads it. This is what annoys me most about the installer. I even record this video so that if you don't want to read it, then at least watch the video, because when they moved it, wedged the correct spacer, everything worked. The accordion is the same. There are a lot of nuances in shimming the accordion because the wedges are placed mirror-like from the hinges. So it's not just that all the sashes are the same. The wedges need to be distributed at a specific step so that the accordion works properly and doesn't sag. Drainage should be present on all windows, on horse frames, on doors, on a spar, on an accordion, everywhere. It happens that drainage is done incorrectly in the workshop or not done at all. So I recommend that installers check whether there is drainage in the frame when you install the product. If not, check and shoot on site. Check if there is drainage in the sash, whether he did it correctly. There may be hidden drainage, there may be open drainage. In development, for example, I had cases when the frame arrived disassembled and they simply assembled it incorrectly with the drainage facing inward. Or the already assembled frame was turned somehow with the drainage facing inward and was assembled incorrectly. Therefore, drainage, must be from the street. It must be done correctly. Because if you don't do that, the water won't drain away. Especially with sliding systems, that's where it tends to start leaking inside. In general, these moments are important. You need to take a look, maybe even spill it somewhere. Check how the drainage flows. And keep an eye on these details. I've also mentioned before that it's essential to check for verticality and horizontality. It also mentions the connection of two frames. Between the connections, I already said that you need to either foam or pistol or some term, so you need to seal the connection, otherwise there will be drafts later on. Here I repeat, it also talks about straightening plates, about the humidity of their installation, that it should be under 3 glasses, under all of them. The plate should be of the required width. And a photograph is provided when we were checking, and at the site the installer's straightening plate slipped, and it was not under all the glass. This is a huge defect, so it's a big problem. Of course, we fixed all of that, but if we hadn't, over time the glass would have slipped, and that would have caused a problem. There is also insulation. of reinforced supports, there are small indications, small indications of what kind of inserts there should be. Such nuances to check the quality of the glass for defects by installing it evenly in the glass unit. So before you insert the glass, make sure there are no chips, scratches, or maybe some leftover sealant. Sometimes there might not be any sealant, or there could be some voids. We check, and if everything is fine, we install it. It's very important to correctly identify the side of the glass. Don't trust all those stickers. The stickers aren't always on the inside, and they're not always applied correctly. I have a separate video for installers on how to correctly identify the side of the glass. There, on the extreme side, somewhere the coating comes off, somewhere it doesn't come off, there a golden stripe remains, and somewhere it's black. Therefore, the side of the glass can be determined like this. I can throw it to anyone who needs it. Then, you can also determine it just by looking at it. Multifunctional glass, it is mirrored, it should reflect from the street. If there are no mirrors, then perhaps something was set up incorrectly. I had a project where they had to flip the double glazed units after they were installed, not just one project. This has happened often, so I tried to pay close attention to it. Here is the choice of the glass side. This is a mega important task, and in fact, it's not as simple as it seems. Pay attention to this. Crushing of the seals in the frames, especially in the energy efficient systems, can happen when they install the double glazed unit, and sometimes when they put the unit in, they start to move it a bit and the seal gets crushed, or it gets crushed while they're inserting it. They don't notice this, they've already pressed it with clamps, and then it's very difficult to align it. You have to take out the glass unit. Therefore, when you install a double glazed window from the inside, be sure to check that the rubber bands are not dented anywhere, that everything is level. Installing a seal under the headquarters is such a small thing, it would seem, but it is such a big problem because no one can install it properly. What I mean is we have this sliding door system where the double glazed unit is installed, then the trim goes on, and the seal is inserted between the trim and the glass. First of all, they keep inserting it the wrong way for some reason. It has this skirt, an extension, and it should be facing down. So figure out how to properly insert the seal under the trim. Look at the drawings. If you don't understand something, just ask. So it's really important to insert it correctly. Next, if it doesn't fit, take a spatula and press the glass in, then tap it in along the line. Just tap it in along the perimeter to the line so that the glass presses in as much as possible. Then it will be easier to push it in. If it still doesn't fit, use a soapy solution or some kind of silicone spray. So you need to lubricate it with something to make it slide better, and then it will fit in there more easily. If it still doesn't fit, maybe the sealant is the wrong one. You need to change it a bit. Try to push it in, and if it doesn't work, then change the sealant. If it's being pushed in, it needs to be leveled out, because if you just use your fingers, sometimes it ends up with little dents, like you poked it with your fingers, and it stays that way. That's not nice. Level it out. Next, you can't stretch it. It is a very big problem when the glazing bead and seal are stretched. And then they leave, and it shrinks, and then there are 3 centimeter gaps in the corners where the sealant has sort of tightened. So it needs to be installed in a way that allows for expansion, smoothing it out well. We place it in a way that allows for expansion. We keep placing it. The ideal scheme, even in the catalog, they indicate how to do it. You have a solid seal, you just cut it at the corners to fit the 45 leg. It is solid, and then it converges at the top, and you glue it there. But you can do it from 4 pieces. Just make sure they're not stretched tight, but rather installed with some space, and you definitely need to glue them at the corners. Glue the sealant pieces together, then there will be fewer problems. We sealed it, glued it, and that's it. It will be standing properly then. Next, we have the joints. This is the final stage. I'll also try to go through this quickly. Actually, not many people can do the joints properly. It seems like a small detail, but it's actually not the most critical stage, yet it's very important. First, check that the joints are strictly done according to the project, because often the sealants used are not the right ones, not applied in the right places, and so on. The outside is smeared with the inside sealant, and the inside is smeared with the outside sealant, where it says to apply with a caulking gun. You don't use that. So the main thing is that it corresponds to the project. So if you're given the drawings, make sure to check the project to ensure everything matches up clearly. They weren't foolish people who drew that up. The butyl tape must definitely be applied, I've already mentioned this, under the pressure plate. Installing the pressure plates, in general, this is a constant issue because with the edge pressure plates, you have the glass, and here, whether it's a sandwich or some kind of compensator, a rubber seal, it doesn't matter. It needs to be in the same plane as the glass. When you screw the clamp on, it should not come out. If it turns inside out, solve this problem. Do not leave it like that. It means the rubber needs to be changed. It means that the workshop may have installed something wrong. The designer may have designed it wrong. There are different situations, so make sure that the clamps are not turned inside out. Next, once you've confirmed that they are even, bring them together. When pressing the lid, there should not be a gap larger than 0.5 millimeters, maybe a maximum of 1 millimeter. Try to bring them as close together as possible. A gap of 2 to 3 millimeters is unacceptable. How is this done? You have a horizontal beam, which is a lintel, and you can't extend it. So accordingly, you press the vertical pressure plates against it. Because mainly there are thick double glazed units and self-tapping screws, it's quite simple to just loosen the screws, pull it a bit tighter, and then screw the self-tapping screws back in. If this is not enough, sometimes you can even slightly shift the hole on the vertical pressure bar and bring it together. A couple of millimeters won't be noticeable, but it will help eliminate that gap that forms between the post and the lintel. If it really doesn't work out at all, sometimes it happens that at the corners it doesn't fit because the unit came in a bit thicker and there's not enough length. In that case, you should contact the factory to have them replace it with a new size, cutting you a new pressure plate and cover. You also need to make sure that there are no gaps between the pressure plate and the cover, so everything is nice and even. Rubber, often the pressure plate, but comes from production with rubber seals at the ends that are extended by 5 centimeters, 10 centimeters, or 3 centimeters. We installed the vertical one, we installed the horizontal one, and it turns out that where the vertical is, this rubber seal is sticking out, and sometimes they just leave it like that and drive away. The client is looking at it and thinks it doesn't look very presentable. Well, is it really that hard to trim the rubber? Make sure to trim it. Make sure that the product is something you wouldn't be ashamed to show to the client. This is important. Sometimes they just slap on the edge seals that go around the perimeter. Everything is turned out like this and something is messing with the wall. You need to apply the sealant like this, right on the edge. You need to do this properly according to the drawings, trimming, fitting, and joining everything so that it can be sealed and waterproof correctly. Seal the joint around the outside with a caulking gun from the bottom. You can use a caulking gun, some other sealant, or liquid waterproofing. You must understand that sliding doors reach to the floor, doors reach to the floor, windows reach to the floor, facade systems reach to the floor. The lower joint on the street side is the most critical joint. There's always water there, a lot of water, and there will constantly be leaks, soaking the mounting foam and so on. So you need to create some kind of galvanized cutoff there with sealant, apply calc, or just foam it and seal it with something. Liquid waterproofing, Franco steel, maybe some kind of EPDM membrane, bituminous waterproofing, various mastics, really anything will do. Just make sure to do whatever you need to make this joint airtight. It must serve the function of waterproofing. Take this as seriously as possible, because sometimes they just foam it up, slap some sealant on and leave. The project depicts walking with a cartlinger. Then the client calls and says that there are leaks and some stains in the house. Yes, that's it, water is getting in, because they waterproofed it properly from the outside. This is a very important point. Even if you don't have this in mind, raise the issue. If you are an installer looking at it, you should understand that your lower units should be well waterproof. If you have a window on the parapet, God bless it. It doesn't matter if it's at floor level, there must be waterproofing. Regarding sealants, this point is also bound to be confused. In general, the logic is lost because the sealant stis A is vapor permeable. I already said it should release steam. Stis B is vapor barrier. If you spread it on the outside, then the whole picture changes. In general, you get moisture that is in the unit. It cannot go outside because there is already a vapor barrier layer and not vapor permeable, and it goes inside. Most likely then there is mold and so on. That is in fact competent execution of everything, and the use of sealants exactly for their intended purpose is an important point. Why is it written on the box that it is internal? Why should it be spread on the outside? If tapes are used, this is also an important point. 90% of installers don't know how to apply tape properly. How do they do it? They secured the frame, then they stuck the tape to the frame, foamed it up, and just kind of slapped the tape on and left. Now, that's it. The foam has torn the tape off in some places, pushed it out, and there are all these uneven blobs on the tape. The tape is stuck on crooked. You definitely can't do it that way. You need to foam it, then wait for the foam to dry and carefully cut it off. You need to apply primer to the wall because without primer, the tape won't stick properly. Next, there should be some expensive tape, like the good one from Gazy. Next, you should carefully stick it on. The tape should be applied at a 90-degree angle like this. It's not just like that, because it will get in the way of the finishers. The finishers will come and just tear it off. I've completely moved away from using tapes because you can't really control them properly. It's also impossible to train installers to apply it properly. They don't even have the task of doing it properly. They just slapped it on and left. Even those installers who know how to do it, they still do it. The tape can still come off over time. In general, I don't really like this topic, so I usually use sealants. You need to foam it well. It also seems like, what's so hard about foaming? Not everyone can foam properly. If you have a large width or depth, you need to foam in several passes, spraying it with water so the foam can absorb the moisture. You need to know how to do it properly, so there are no gaps, because sometimes there are holes the size of a finger where you didn't foam enough. Learn to foam properly, use professional foam, and get good professional guns. You should practice so that you won't be embarrassed and nothing will leak or freeze later. For example, if there's a large gap, you can use foam board. Take a piece of foam board and foam it on both sides. Why pour foam into a bucket so it bubbles up like that? Of course, you shouldn't do that. Take it, it's not difficult, 3 or 5 Panoplex, cut a strip, foam it, insert it. Then we carefully and evenly trimmed it along the stud or in pairs. We trimmed it with a knife, took some adhesive, and applied it all. We stuck the painter's tape on, applied it, and then tore it off. Well, that's beautiful. If we have an installation that extends out, we use foam board around the perimeter and the joints, like a sleeve on the outside. If the product is extending out, this foam board should be fastened to the concrete with something. We use these plastic mushroom-shaped dowels to fasten the foam board to the opening. But we always use foam glue, an unusual foam. We buy foam glue specifically. You take a strip of foam board, stick it with adhesive foam to the opening, and then fasten it with those dowels. A very important point is that I bring this Pinaplex and sandwich to the site in sheets because the width is different. The height from the floor is different. It is more convenient to cut it on site. Therefore, you need to be able to cut the Pinaplex and not sandwich. If the sandwich panels are cut somewhat okay, people still cut them like that, but they can't handle the foam board at all. It's all crooked. The customer ordered some multi-million-dollar expensive products. He comes, and it is clear that you have a disgrace for crooked Pinaplex. So learn to cut foam board properly. This shouldn't be done with a stationary knife, and a sandwich shouldn't be done with a knife either. At the very least, there should be a jigsaw. I have Pinaplex guys at the site. They stretch this tungsten string or something there, connect it to electricity, and like that, they built themselves a table. They stretch this Pinaplex, maybe with some kind of circular saw, maybe with a jigsaw. I don't know. You need to come up with something. You'll be like specialists. I have those. Fitters who are adequate, everything is always smooth with them. Those who are clueless will do everything haphazardly and messily. So think about it. Check online. For example, in the zone, there are even these special machines that can be cut. I also found some that use a wire, so you can find a solution to cut it more evenly. Structural corner. The structural corner where the two pieces of glass meet needs to be insulated on the inside. You can either insert a Velotherm or cut a square out of foam board and glue it in. That's also acceptable. When you bring two glasses together, you should really try to bring them together so that there is an equal gap. I usually leave a 5mm gap, and you must set it up so that everything is on one plane clearly. Sometimes when you have a tall glass unit, it can bend a little under its own weight in the center, which results in the gaps at the bottom being smaller than those in the center. Let's say you have 5mm at the bottom and 7-8mm here. You definitely can't cover it up like that. It needs to be aligned. How do you align them? Or there's some kind of corner suction cup, or you can use two suction cups and some kind of rope. So somehow tighten it up, or use some tape. We need to find a solution. Tighten it up, then seal it, and when the sealant hardens, it will hold everything in place. But everything needs to be precise. Not everyone knows how to seal the structural corner. You need to apply painter's tape. A special sealant is used. If we take the 791 Kartlinger for the bottoms, then for the structural seam, it is 195. A higher quality special sealant is used for the structural joint. You can't just use regular sealant to do a proper job. You take structural sealant or some kind of Dow Corning. It doesn't matter how good the sealant should be. We applied painter's tape, filled it with sealant, and then we smooth it out with a spatula. We try to make one smooth pass like this so that it's as even as possible. Don't smear it with your fingers like this or with the spatula like that. Exactly, to make it even, we removed the tape and it dried perfectly. Sometimes they also use some sandpaper, like zero grit, to smooth it out, or while it's still wet. I know some specialists take a sponge and a soapy solution to smooth it out like that. Making a beautiful structural joint is truly an art. Not every installer can do it. That's why this is a very important point. The drainage caps must be installed on the products. If you have a drainage hole, then a cap definitely goes there. The last point is that the products should be neatly coated with a sealant and so on. But I already said that I just had it happen that everything got dirty. So if you happen to get something dirty somewhere, well, wipe the item off. Cover everything with masking tape. Try to make your work look beautiful and not embarrassing to show to the client. Well, that's basically it. I hope you liked it, and I recommend sharing this video with everyone you know, especially installers. If you're the owner of an installation company, spread this among your installers so they can learn. If you're an installer, take a look yourself and pass it on to your colleagues. Let's publish some installation chats. Let all the installers, the whole world, learn from mistakes, from my experience, and from the information I've shared at us. It's important to understand why this matters, because I want the level of qualification to rise so that installers work well and so on. They understood why this is important, because I want the level of qualification to rise so that installers work well and so on. If you want to work with me, leave your contact information in the comments and get in touch with me. I will definitely keep it because I need installers in Chelyabinsk. We have projects there, as well as in Rostov, Sochi, St. Petersburg, and so on. Objects throughout Russia, Europe, and Latvia. Now, the facility should be in Moldova, so, well, I hope it will be concluded with the calculation. If there are good teams of fitters who are really ready to work with experience, please contact me. I am ready. If you don't have experience, then I'm also ready. If you have the right attitude towards work, If your attitude is to stick it on and leave to somehow make some money, then this is not for me. Such people immediately end up on my blacklist. If you have a responsible attitude, if I send you a document, you study it, you study the video, you meticulously ask 1,500 questions, there you will seal the rubber bands, screw in all the screws, check everything 5 times with a level. If you have that kind of approach, you'll have a future, you'll make money, and clients will line up to have you install for them. But if your approach isn't like that, then it's better to do something else rather than installations. In general, I'll attach that file in the description of the video with a link in case you need it. I'm sure many will find it useful. I'm making this available to everyone, so click the link, download it, and share it with your installers. Let's work smart and do a great job together. Give it a thumbs up if you like the video, and subscribe to the channel. All right, everyone, goodbye, and see you in the next videos.